Good afternoon, class. We are looking at pre-calculus practice test number 3, covering chapters 5, 6, and 7. Chapter 5, trigonometric functions. Chapter 6, periodic functions. That's what we are covering in this part. Graphs of sine and cosine function. Well, a complete cycle of a sine, y equals sine x, x is between 0 and 2 pi. The key points are 0, 0, pi over 2, 1, pi 0, 3 pi over 2 negative 1, and 2 pi 0. So we cut that into 4 arcs, this part. So let's give them numbers. 1, 2, 3, and 4. And we evaluate the endpoints. That gives us the 5 key points. The domain is all real numbers. The range is -1 to 1. T is 2 pi. The period and amplitude is 1. Now, this continues indefinitely on both sides. Cosine function works in the same manner. Of course, with the y-intercept being 0, 0 for sine and 0, 1 for cosine. Sine and cosine are ultimately the same. Sine is cosine of x minus pi over 2. Now, if you happen to have a sine omega x, then it changes the period from 2 pi to 2 pi over omega. So for sine and cosine, basic functions, period is 2 pi, amplitude is 1. If it's a sine omega x or a cosine omega x, period is 2 pi over omega, amplitude is the absolute value of it. If we make it more generalized, a times sine bx minus c plus d, it's a good practice to take the b out. So we can see a is the amplitude, okay, and c over b is the phase shift. And of course, t would be 2 pi divided by b. Sometimes they use it in this format, sometimes they use it with omega. Either one, okay? And the period is 2 pi over b or 2 pi over omega. Amplitude is absolute value of a. Phase shift is c over b if you go with this one, or phi over omega. C and phi less than 0, then phase shift is to the left, positive would be to the right. Note, the midline of a function is the horizontal line midway between the maximum and the minimum value. That means this. So for y equals sine theta, the midline is the line y equals 0, which is the horizontal axis. And in general, this would be the case. Y equals d. This case would become b. Okay? So that's the synopsis of a graph of a sine function. And so let's look at a simple example. We want to find the amplitude, period, intercepts, and phase shift of the function. Sketch the graph of y equals negative sine of pi over 3x plus 4. And reminding everyone of the general case. So first and foremost, the amplitude, you look at this function, and the absolute value of -6 is the amplitude. T is 2 pi over omega. 2 pi divided by omega, or 2 pi divided by b if it's used with the b. And in this case, is pi over 3. So 2 pi over pi over 3. And that makes it 6. And since there is no number sitting next to it, there is no phase shift. So what we do, in order to come up with the 4 arcs that was mentioned, we're going to divide this into 4 equal parts. 6 divided by 4 is 3/2. And since there is no phase shift, you start with 0. If there's a phase shift, you start with the phase shift. So from 0, we go to 3/2. And then now from 3/2, add another 3/2. You get 6/2 or 3. Then from 3 to, now add 3/2 and another 3/2. You get 3 to 9/2, 9/2 to 6. Now you have a choice, evaluate the function at the endpoints, or just remember the effect of 4 is to go up and down, positive for up, negative for down. So you can just look at this part, okay, and the endpoints, 0, 3 halves or 1.5, 3, 9 halves or 4.5, and 6. You look at those points, and we're going to go with this function. First, 0. If I put 0 here, sine of 0 is 0. Minus 6 sine 0 is 0. If I put 1.5 instead of x, let me do that so you can quickly see that. If I replace this with 1.5, that means minus 6 sine of 1.5 power 3 means power 2. And sine of power 2 is positive 1. With negative 6, the product is negative 6. What about 3? Let me also do 3. So if I replace this with 3, I get minus 6 sine of pi. Sine of pi is 0, so I get 0 here. And I'm going to leave it for you to figure out 4.5. Plug in 4.5, plug in 6. 6, you can see 6 over 3 is 2 pi, and sine of 2 pi is 0. So you can figure out those pairs, and let me erase my work. So we're going to put 0, 0. 3, 0, 6, 0. Those are the intercepts. Those are the x-intercepts. And these happen to be two y-intercepts. I'm talking about this function, not this. And 1.5, negative 6, 4.56. So those two pairs, right? 1, 2, 3, 4, 5, 6 down, 1, 2, 3, 4, 5, 6 up. And here's the graph for this function. But that's not what we want. We want this function. So we're going to shoot it up by 4 units. Vertical shift, 4 units up. So all you have to do, same x coordinates, add 4. This becomes 4, negative 2, 4, 10, 4. This is also called the midline, by the way. Y equals 4 is also called the midline. So add 4. So those are the new points. Just basically those points go up by 4. This is the graph for one cycle. You continue indefinitely on both sides. That would be the graph. Quickly, the second method, I'm not going to repeat everything, but I'm going to just quickly show you that the amplitude, the period, this is from the previous page. There is no phase shift. We cut the t in 4 parts and we get those. And this is what we did, right? This is just from the previous page, nothing brand new. Okay. So the vertical shift by 4 units gives us those pairs, and you can also go to the left or not, doesn't matter. So those, so from here you start, okay, and you put those pairs, 0, 0, now 0, 4, okay. 3, 0 is 3, 4, 6, 0 is 6, 4 now, because we are going back to original function. So these 3 points. So instead of being along the x-axis, they're along the line, the horizontal line y equals 4. The other 2 points, 1.5 minus 6 is 1.5 minus 2. 4.56 is 4.510. That's a complete cycle. And you're going definitely on both sides. The point being, You can go either way. You can just go with the original function, with the original key points, and come up with the answer. Find the amplitude period intercepts phase shift for this function. Y equals to cosine 3x plus pi over 2, and again reminding you of what they should look like. So the very first thing I want to do, I'm going to bring the 3 out. This becomes x, and this becomes power 6. Please understand what is happening, because 3 times power 6 is power 2. Now, clearly the amplitude is the absolute value of 2 or 2. T is 2 pi over omega, 2 pi over 3. And this is the phase shift, negative pi over 6. 2 pi over 3, and the phase shift, negative pi over 6. We're going to get to the 4 arcs, so we're going to divide the t by 4. 2 pi over 3 divided by 4 becomes 2 pi over 12, or pi over 6. Which means, because of the phase shift, we're not going to start from 0, rather we start from here, and we go by the t to the right. So minus pi over 6, and then minus pi over 6 plus 2 pi over 3. That is where one complete cycle is. So from negative pi over 6 to pi over 2. This is pi over 2, this is negative pi over 2, so 1/3 of the way roughly here we start. Okay, just to give you an idea, let's just, so somewhere here is negative pi over 6, okay? And now, what about this one? We start with negative pi over 6. And then we add, remember when we divided the t by 4, also it gave us pi over 6. So we add pi over 6. So just to give you an idea of what we want to do. Minus pi over 6. Now we're going to add this t divided by 4, it gives you 0. The next one is from 0, now add pi over 6. The next thing starts with pi over 6. Add pi over 6, 2 pi over 6, or pi over 3. And we continue. Okay, so minus pi over 6 to 0, 0 to pi over 6, pi over 6 to pi over 3. And now if you add pi over 6 and pi over 3 becomes pi over 2. So those are the 4 arcs. And so we start putting the values for those 5 key points. Minus pi over 6. So if you, let me erase my word. So if I put this one in here, I hope you see that I get 0. So I get 2 cosine of 3 times 0 is 0. So what is cosine of 0? 1. So I get 2. So this one is 2 as an example. So let me just put up here 2. Let me erase my work. So this is 2. If I put 0 here, okay, it might be here easier to put it here. It doesn't matter. You get 2 cosine of pi over 2. And cosine of pi over 2 is what? 0. So this gives you 0. So let me erase the work. So 2, 0. Let's put pi over 6. Pi over 6 is easier to put it here. And pi over 6 is pi over 3. Pi over 3 times 3 gives you 2 cosine of pi. 2 times cosine of pi is negative 1. So you get negative 2. And you can figure out the rest. You get 2 0, -2. If you put pi over 3, and pi over 6 is pi over 2. So 3 times pi over 2, 3 pi over 2 cosine is 0, and that pi over 2 is 2. So those are easy to figure out. I'm going to erase my work. And so somewhere here is negative pi over 6. And it's 2. 2 is here. And the x and y scales may be different. So somewhere here. Then we have 0, 0 is here. Then we have pi over 6 again, somewhere here. And it's -2 here. Then pi over 3 is somewhere here. It's 0. Pi over 2, 2. And that's one complete cycle. Now go indefinitely on the right, indefinitely on the left. There you have it, and you're done. So that's how you graph sine and cosine functions in general. Cut them into 4 equal parts. All right. Let's look at other functions, everybody. Tangent, cotangent, cosecant, and secant. A complete cycle for tangent goes from minus pi over 2 to pi over 2, because remember, you want to cover everything. So y equals tan x, which is sine over cosine. Domain, denominator can't be 0, cosine can't be 0, x can't be 2n plus 1 times pi over 2. Range negative to positive infinity. All trigonometric functions are odd, except cosine and therefore secant. So that's an odd function. And the period for tangent and cotangent, both of them is pi class. Tangent and cotangent, the period is pi. X-intercept, where the numerator is 0. Sine is 0 at n pi, so n pi is 0. So I hope it's clear to everybody. Vertical asymptote, where the denominator is 0. Cosine x is 0, 2n plus 1 times pi over 2. In other words, odd multiples of pi over 2. This one means multiples of pi. Cotangent, a complete cycle goes from 0 to pi. And it's cosine over sine. So domain, sine can't be 0, so x can't be n pi. Range is just like tangent or real numbers, the odd function t equals pi. Vertical asymptote, the denominator is 0, sine is 0, so x equals n pi. X-intercept, cosine is 0, that means 2n plus 1 power 2. I hope you realize how easy it is. If you look at this one, you can answer every question. Cosecant basically is 1 over sine. So graph the sine function and then flip it over. So y equals cosecant is 1 over sine. Domain is whatever makes sine 0 is excluded. Range from negative infinity to negative 1, union 1 to infinity. Both ends, negative 1 and 1 are included. It's an odd function. T is 2 pi, just like sine and cosine. And VA, whatever makes the denominator 0, 0, x equals n pi. In other words, just like cotangent, the VAs are x equals n pi. Secant is 1 over cosine, everybody. And 1 over cosine, the domain x can't be 2n plus 1 pi over 2 because you can't make cosine 0. Range is just as cosecant. It's an even function because cosine is even. T is 2 pi, and vertical asymptote, whatever makes the denominator 0, 2n plus 1 times pi over 2. So to understand those, you want to go back to their definition one more time. Tangent means sine over cosine. Cotangent is cosine over sine. Cosecant is 1 over sine. Secant is 1 over cosine. That's how you figure things out, everybody. Now we want to find the domain and range intercept whatever we can and sketch the graph of one complete cycle for y equals tan of 1/2 x. And I'm going to remind you what we just mentioned. Y equals tan x is sine over cosine. Period is pi. Vertical asymptote, set the denominator equal to 0. That would be the vertical asymptote. Cosine is 0 at 2n plus 1 pi over 2. Domain, whatever makes the denominator 0, exclude that. Range is negative to positive infinity. X-intercept n pi 0, whatever makes the numerator 0. If y is equal to tan of omega x, then t is pi over omega. And so right away, because this one is 1/2, by the way, this is one complete cycle. So t would be pi divided by 1/2, and that becomes 2 pi. In other words, instead of going from negative pi over 2 to pi over 2, it's going to go from negative pi to pi. When that happens, you cut this in half, okay? So when you get pi, so from negative pi to pi, that's what happens. Now, let's look at the domain. If you look at the domain, all you have to do, replace the pi with 2 pi, everybody. I want to show you how easy it is to figure this out. So if you replace this with 2 pi, the 2 cancel the 2, and domain, x can't be 2n plus 1 times pi. Range is the same range, all real numbers. Vertical asymptote, okay, 2n plus 1 over 2 times pi. Replace the pi again. Wherever you see pi, put whatever you have here. 2 pi, this cancel each other. And we get 2n plus 1 times pi because the 2 goes away. Example, x equals minus pi, x equals pi for the first part. So those are the vertical asymptotes for one complete cycle. And I hope you see that if I put 0, of course, I get 0. This one, if I put minus pi over 2, half of that is minus pi over 4. Tan of that is negative 1. This one is positive 1. Pi over 2 times 1/2 is pi over 4. So those 3 points, this one, negative pi over 2, 0. Negative 1, my apologies, 0, 0. Pi over 2, 1. And it almost looks like y equals x cubed, but it's between negative and positive pi over 2. That's the graph. We're done. Very straightforward, everybody. Find the amplitude, period, intercepts, and phase shift of the function and sketch the graph. Y equals 3 cosine pi x minus 4. Well, amplitude is, again, reminding you of that. Amplitude is absolute value of 3, which makes it 3. A period, 2 pi divided by coefficient of x divided by pi is 2. Nothing next to it. There is no phase shift. You cut the period in 4 equal parts. Divide 2 by 4, you get 1/2. There is no phase shift class. So you start from 0. The next one would be 1/2. Just add 1/2, you get 1. The next one is 1 to 3 halves. The next one is 3 halves to 2. So those are the 4 arcs. And so you are going to evaluate the function at the endpoints with the vertical shift of 4 units down. So let's plug in 0. If I plug in 0 here, cosine of 0, let's just actually evaluate a few of. For 0, it's 3 cosine 0 minus 4. Cosine 0 is 1. 3 minus 4 is -1. So this one should be -1. Let me do 1/2. 3 cosine of 1/2 mixes pi over 2 minus 4. This is 0. That gives you -4. So this is -4. Let me do one and then I let you do the other two. So over here, if I put 1, y becomes 3 cosine of pi times 1, which is pi minus 4. Now this is 3 times, cosine of pi is -1 minus 4 is -7. So this is -7, everybody. So if I have those 3, I can easily find the rest of them. Let me erase my work. So I hope everybody can plug in, just plug in and evaluate it. And again, d equals -4. Okay. So what I did, instead of working with this and then moving it down by 4, I just went to the original function. 0, -1. This is 0, everybody, okay? This is -2, and so on. 1/2, and by the way, this is 0.5 or 1/2, and the scale along the x and y axis, they don't have to be the same. 0.5 and -4, this is -4. This is 1 and, okay, first 1 and -7, my apologies, 1 and -7. Then 2, okay, so this is 2 and -1. So 0, -1 here, so those are the ones. Then we have 1/2, this is 1/2, -4, and then 3/2 or 1.5, -4, and put them together. And you continue indefinitely on both sides if they say just graph. But this is asking for one complete cycle. Find the domain and range and vertical asymptotes for this function y equals cosecant pi x. And reminding you, when y equals cosecant x, you write it as 1/sine, you can figure out everything. What is the domain? Whatever makes the denominator 0 is out. So x can't be n pi, and vertical asymptote x equals n pi. The period is 2 pi, it's an odd function. The range are real numbers except in between -1 and 1. X-intercept, we don't have any. Okay, and so the very first thing we have to do is to figure out the sine function, because you just completely ignore that and then answer some of it at the end. You just graph y equals sine pi x. So obviously the amplitude is 1, the number sitting in front of sine, the amplitude, the absolute value of that. The period is 2 pi divided by pi, which makes it 2. There's no number sitting next to it, there's no phase shift. And we cut the period into 4 equal parts. You divide this into 4, you get 1/2. So we start with 0, and then we go to 1/2. And we start with 1/2, 1/2 and 1/2, we go to 1. Then we start with 1, 1 and 1/2 is 3/2. Then we start with 3/2, and we go to 2. So those are the parts that will give us 4 arcs. Now at the end points, we're going to plug in and evaluate. So let's start with 0. If I plug in, I'm talking about this one, everybody. So if I plug in 0, sine of 0 is 0. If I plug in 1/2, I get sine of pi over 2, which is 1. If I plug in 1, I get sine of pi, which is 0. If I plug in 3/2, sine of 3 pi over 2 is -1. If I plug in 2, sine of 2 pi is 0. So these are what we get. I'm going to erase my mark. So we can easily see how that works. Again, for now, we are ignoring the cosecant. So we graph y equals sine pi x. So those pairs 0, 0, 1, 0, 2, 0. 0, 0, this is 0.510, this is 1.520. So those are the 3 points. Then we have 1/2 or 0.5, 1, and then 3/2 or 1.5, -1. That's the graph of sine. What about cosecant? Flip it over. Flip over the graph. Looking like that. Just flip it over. Domain x can't be n. X can't be n times pi. Okay. To have an understanding, one easy way to understand this. You see this pi is t over 2. Generally speaking, is 2 pi over 2. So replace the pi with half of t. T is 2. Half of t. Half of 2 is 1. 1 times n. That's why. Range is the same, -infinity to -1 included, union 1 to infinity. Vertical asymptote, if x can't be n, then x equals n is the vertical asymptote. For example, 0, 1, 2. And if you graph those 3, again, just one complete cycle. And it continues indefinitely on both sides. Okay. This just is asking for one complete cycle. So a quick recap. You want cosecant, you have to go to sine. Ignore that, graph sine. How do you graph it? You come up with the amplitude, you come up with the period, you cut the period into 4 equal parts, and therefore 4 arcs and 5 key points. You graph the sine. Flip it over, becomes cosecant. Just pay attention how you answer for the domain, range, vertical asymptotes. Okay. T is 2 pi, and this pi is half of that. Same thing here. So you put half of the t here to find the domain and the asymptote. Couple of extra examples worth looking at. Find an equation of the graph. Okay, so what do we notice? And that's the key. Let's look at a few easy points. This one, and this one. Notice this is a complete cycle, but looks, and let's write those 2 points too, right? 1, negative 2, 3. This would be an inverted sign. In essence, note that this is a reflection over the x-axis of the sine function with no phase shift. So if you flip this over, it becomes the regular sign that you are all familiar with. So we're going to use a sine omega x, no phase shift. The amplitude, normally this is 1, negative 1, okay? And whatever this one is a negative one and this one is positive one, so the amplitude is 2. Absolute value of negative 2 or 2. Or you can say, if you want to find the amplitude, you can say max minus mean divided by 2. Let me just show you that one. You can use this formula and say max minus mean. That's the amplitude. It's very straightforward. So A must be negative 2. How do we know it's negative? Because we know the sine function and this has flipped over. The period is given as 4, and we know t, the period is 2 pi over omega. So period, let me erase my word. The period is 4 on the one hand. On the other hand is 2 pi over omega. And that means omega is 2 pi over t. And that means 2 pi over 4 or pi over 2. So going with this formula, let's plug in. Let me erase my work. Let's plug in negative 2 here, negative 2 sine of pi over 2x. And that's the final answer. Write the equation of a sine function such that the amplitude is 3, the period t is 2 pi, and phi over omega is negative 1/3, the phase shift. Let's go with one of those formulas. For example, a sine omega of x minus phi over omega plus b, and let's plug in. Well, what can we plug in first? T is 2 pi over omega, which means omega is 2 pi over t. So 2 pi over t. We can calculate the omega. 2 pi over t. 2 pi over 3 pi, and it's equal to 2/3. Everything is explained here except b. B is missing in action, therefore b must be 0. Now let's plug in. Replace the a with 3. So y equals 3 sine of, replace the omega with 2/3, x minus phi omega with negative 1/3. So minus, so it's important to know, minus negative 1/3 or plus 1/3. In other words, past this one is minus negative 1/3. And you're done, but sometimes they just put the 2/3 in, becomes um, 3 sine 2/3 x, 2/3 times 1/3 is 2/9. So you can write it as such, or this one, 3 sine parentheses 2/3 x plus 2/9. Makes no difference, it's the same thing, everybody. Another extra example worth looking at, draw a scatter plot and find a sinusoidal function of the form y equals a sine parentheses omega x minus 5 plus b that fits the monthly temperature data for Indianapolis. So here's the given information, everybody. So just to have an idea what this means, this will correspond to the pair 1, 28.1. This will correspond to the pair 2, comma 32.1, and the last one would be 12, comma 31.6. So those are the points, those are the pairs. And so I'm going to assume everybody can plot pairs. So when we plot the pairs, 1, and this may be hard to read, about 28.1, 2, 32.1, and so on and so forth. So the graph looks like a sinusoidal function. So we are going to make it and fit it into this function. So reminding you of a couple of things. When we want this, we got to start with A, and A is max minus mean divided by 2. And I'm going to remind you, here's a, never mind this one, a basic sine function. Let me just write this, a basic sine function looks like this, which means this is 0, 0, this is pi over 2, 1, this is pi 0, this is 3 pi over 2, negative 1, this is 2 pi 0. So max minus mean, we have to look up the maximum and minimum value here. So this is the minimum value, and this is the maximum value. So the minimum value occurs in January, which is 28.1, and the maximum value happens in July 7th, which is 75.4. July, month 7, I mean. So monthly temperature. And so max 75.4 minus mean 28.1 divided by 2, that's what we are looking for. And we get 23.65. So far so good, we got the A. Now the vertical shift B is the sum of the two divided by 2. Now add the two numbers instead of subtracting and divide by 2. So this was 75.4 minus 28.1 divided by 2, resulting in 23.65. This one is 75.4 plus 28.1 divided by 2, resulting in 51.75. Now, it's extremely important to see this is a monthly temperature. How many months? 12 months. That means it repeats. On a monthly basis, we have 12 of them. So the period is 12 because it's a monthly temperature we are discussing. So T, which is 2 pi over omega, must be equal to 12 months. And therefore, omega must be 2 pi over T, or 2 pi over 12, again, 12 months, because monthly, 12 months. Monthly, there are 12 months in a year. So 2 pi divided by 12, which makes it pi over 6. So instead of 0 pi, 2 pi, okay, when we cut this, It's 12 months. We have 0, 6, 12, right? And I want to make sure we understand. A basic sine function, 0, pi, 2 pi. So instead of going from 0 to 2 pi, we're going to go from 0 to 12. Instead of having pi in the middle, we have number 6. Let me erase my word. And let me actually write. Here, y equals sine x. So I want to make sure we understand. 12, this is how it translates. And so the maximum occurs at pi over 2, 1. And it's 1/4 of the way. So t divided by 4, 12 divided by 4 must be 3. That's what happens with the basic sine. Okay. But the maximum occurs instead of number 3, it happens at number 7. So the x coordinate of the maximum value is in July number 7 instead of 3. What does it mean? It's supposed to be 3, but it's 7. Their difference is the phase shift. So PS, short for phase shift, is 5 over omega. 7 minus 3 equals 4. So I hope everybody's clear on that. So let's write this formula. Replace the A with 23.65. Sine of omega, replace it with pi over 6. X minus 5 over omega, replace it with 4. And B, replace it with 51.75. You're done. However, we may distribute the pi over 6. If we do that, everything remains the same except pi over 6 goes inside, becomes pi over 6 times x, this one minus 4 pi over 6 or minus 2 pi over 3. So this is the second way of writing the same thing. This represents this sinusoidal graph. And all you have to do, plug in, for example, x equals 1. It should give you a number close to 28.1. X equals 2, close to 32.1. It may not be exact, so on and so forth. And I highly recommend you try that.